Hello and welcome back to the Artificial Intelligence Masterclass. In today's tutorial, we're going to talk about the variational autoencoders. Now, if you've already done the tutorials on normal autoencoders, you will find that variational autoencoders are extremely simple. So let's have a look. Here we've got our standard autoencoder. And as we discussed previously, what we're doing here is we're taking the inputs or the input vector, we're mapping it onto this vector over here, which is also called the latent vector. And from here, we are extracting our output. So this is called encoding, and this is called decoding, and this is called the latent vector, also called the bottleneck in autoencoders. And what this allows us to do is it allows us to compress our inputs and then decompress them over here. So autoencoders, one use case for autoencoders is compression. You can compress images, audio, video files, and other files in such a way. As we also discussed, an autoencoder is a self-supervised type of deep learning algorithm where the way we train it is we compare our output to the original input and we try to make sure that they match up as close as possible. Now that's our standard autoencoder. What we're going to do here is we're going to make some slight changes to how this is illustrated just to give us more room on this image so we can move things around and add some new components. So there we go. This is exactly the same autoencoder. It's just illustrated in a different way. So we don't have lots of connections here and lots of nodes. We just have one arrow on each side just to give us some more room. But effectively, this is exactly the same thing as we have here. So this is our normal autoencoder. Now, what is the difference between a normal autoencoder and a variational autoencoder? Well, in a variational encoder, we want to add some stochasticity over here. So we want to add some randomness to this latent vector. And basically what that means is we're not going to, here what we're doing right now is we're taking our inputs and we're mapping them onto a latent vector. In a variational encoder, we're going to take our inputs and we're going to map them onto a distribution. And that will allow us to have randomness or stochasticity in a latent vector and reconstruct many different environments, or have some randomness every time we decode this vector. So let's have a look how we're going to do that. All we need to do is, rather than mapping straight to the latent vector, we're going to first map our inputs onto two vectors. One of them is going to be the mean vector. So that's the mean of our distribution. And then we're going to have the standard deviation vector. So these are going to be the standard deviations of our distribution. The means are here, standard deviations are here. And then from these two vectors, we're going to sample our latent vector every single time. So this is called the sampled latent vector. And as you can see, after this is all trained, we're going to be able to have a slightly varying latent vector every single time we generate it and every single time we decode, allowing us to achieve that stochasticity that we're looking for. So that's variational autoencoders in a nutshell. Very simple concept. Once you know how autoencoders work, the step towards variational autoencoders is very simple. Effectively, instead of mapping onto a latent vector straight away, we're mapping onto a mean vector and a standard deviation, then we're sampling the latent vector, and in essence, it turns out that we're mapping our inputs onto a distribution from which we sample in order to then proceed with the decoding. So that's variational autoencoders. In short, if you'd like to read more about them and get a bit more feel for the intuition, there's a wonderful article on Medium. It's called Intuitively Understanding Variational Autoencoders by Irhum Shafkat. And we've got the link here. You'll also find the link in the notes for this course. So there you go. Hope you enjoyed today's tutorial, and I look forward to seeing you back here on the next one. Until then, enjoy AI.